Welcome back to the Deep Dive. Today we are wrestling with a truly colossal figure and a profoundly complicated one in the history of science.
We really are.
James Dewey Watson. This is a person whose single greatest achievement, I mean, we're talking about co-authoring that 1953 paper proposing the double helix structure of DNA.
Right, the Nature paper.
And it didn't just advance the field, it fundamentally altered our whole understanding of life itself. It kicked off the entire modern era of biology.
Indeed. We've got a deep stack of sources here detailing his life. Watson, who recently passed away in November 2025 at the age of 97.
97.
And what's immediately clear from the global media reaction is the absolute duality of his legacy. He is, universally recognized as one of the 20th century's most important scientists.
Unquestionably.
Yet his obituary immediately, and I mean immediately, transitions to the necessity of framing his life as complex and deeply troubling.
And that complexity, that tension, is really our mission today. We need to unpack the full context of his life. We have to celebrate the revolutionary science, the architect of the double helix, while also grappling with the profound career-ending controversy. We're talking about his public remarks on genetics, race, and intelligence, which, well, it led to the very institutions he helped build officially severing all ties with him.
And what's essential to understand as we look at the source material is that for James Watson, the science and the controversy are inextricably linked.
How so?
His later highly inflammatory rhetoric drew directly from a particular philosophical interpretation of the very field he helped create.
Genetic determinism.
Exactly. His belief in the power of genes was absolute, and it became this dangerous lens through which he viewed all of society.
Okay, let's unpack this enormous biography. I think we need to start at the beginning to really understand the intellectual environment that forged this revolutionary thinker.
Let's do it. Watson was born in Chicago in 1928. His father was a businessman. His mother was Catholic, though the sources are quick to note he became a staunch, lifelong atheist very early on.
He even referred to himself as an escapee from the Catholic religion in one place.
He did, which suggests a very early, very firm commitment to empirical reality, But here's the interesting detail about his early ambition. He started out as an avid bird watcher.
Right, bird watching, a hobby he shared with his father. And he was dead set on ornithology, fully intending to make a career out of studying birds. That is a world away from molecular genetics.
It is, and the sources actually pinpoint the exact moment of transformation. It really demonstrates the power of ideas in print. In 1946, he read Erwin Schrödinger's landmark book, What is Life?
Oh, okay.
And that text didn't just intrigue him, it fundamentally shifted his professional ambition entirely. He pivoted toward genetics and the mysteries of the gene. He wanted to understand the physical basis of heredity.
That's amazing. A single book redirects a life. And you could argue, redirects the course of science. And he was academically accelerated too, right?
Very. He enrolled at the University of Chicago at just 15 years old on a scholarship.
15.
Thanks to a liberal policy at the time that encouraged early entry. By 1947, he had his BS in zoology, and then he went straight into a PhD program at Indiana University.
And he chose Indiana for a very specific reason.
He did. He chose it specifically because of the intellectual gravity there. He was drawn by the presence of Hermann Joseph Müller, the 1946 Nobel Prize winner. Müller had spent years laying out the fundamental properties of the heredity molecule through his work on, fruit flies and X-rays.
But the personal connection that really mattered, the one that shaped his path, was his doctoral advisor, Salvador Luria.
Yes. Luria, who would himself go on to win the Nobel in 1969. Luria became Watson's gateway into this incredible intellectual environment known as the phage group.
Okay, this is absolutely critical context. It's his scientific DNA, if you'll pardon the pun.
Precisely. Let's delve into the phage group era because it was a genuinely revolutionary movement. This group, led by Luria and Max Delbruck, was centered on this one powerful idea.
Which was?
Use the simplest possible system to study the gene. So they shifted genetic research away from the classic complex experimental systems like the Drosophila, the fruit flies you mentioned.
Right.
And they moved toward microbial genetics, specifically using bacteriophages.
So for the listener, what exactly is a bacteriophage? And why did studying it make the phage group so central to the birth of molecular biology?
A bacteriophage, or a phage, is simply a virus that infects bacteria. That's it. And the phage group realized that if they could understand how this simple entity, the virus, took over a much more complex organism, the bacterium.
They could understand the mechanics of the genetic material itself.
You've got it. They were looking for the blueprint of life. And they reasoned that the genetic material had to be simple enough to be isolated and studied, but also complex enough to carry all the instructions for replication.
It sounds like they were operating with a real sense of urgency.
Oh, they were. They sensed they were incredibly close to discovering the physical nature of the gene itself. This environment was electric. It attracted the best and brightest because the stakes were, in a scientific sense, existential. They were the true molecular biologists of the time, even before the field had really named itself.
And what was so fascinating is how this revolutionary thinking contrasted with the prevailing scientific consensus at the time regarding what the material of heredity actually was.
Contrasting is, to put it mildly, even as late as 1949, the widely accepted wisdom was that genes were proteins.
Why proteins?
Simply because proteins were known to have this immense complexity, right? All of those amino acids. They seemed complex enough to store all of life's information. DNA, on the other hand, the other major component of chromosomes,
Was dismissed.
completely. It was dismissed by many as a simple, repeating, and therefore information-poor structure. It was called the stupid tetranucleotide.
Stupid tetranucleotide.
It was widely assumed that DNA served only a structural role, like scaffolding. So the entire scientific climate was stacked against DNA being the material of heredity.
But the phage group, because of their intellectual lineage, was already looking past that dogma.
They absolutely were. They were heavily influenced by the Avery McLeod-McCarty experiment from 1944.
Okay.
That work had demonstrated that DNA, not protein, was the transforming principle that allowed one type of bacteria to acquire the characteristics of another. For the phage group, this result was powerful evidence that DNA was the genetic material.
And Watson's early research was part of this.
It was. His early PhD research, using X-rays to inactivate bacterial viruses, was part of this lineage. But his focus soon narrowed from function to structure. He became obsessed with the shape.
So after his PhD, Watson takes a postdoctoral year in Copenhagen, starting in September 1950. He was initially meant to work with Hermann Kalkar on the enzymatic synthesis of nucleic acids.
Right, the actual construction of the molecules, but the sources all indicate it was a mismatch. Kalkar's work was too biochemically focused, too much test tube chemistry, for Watson's rapidly growing obsession with the structural puzzle.
He wasn't interested in the raw components, he was interested in the architecture.
Exactly. So he then pivoted to experiments with another member of the phage group, Ole Malu. They were using radioactive phosphate tracers to see which phage components actually infected the host bacteria.
Trying to confirm the DNA is the gene concept.
Right, by tracking radioactive labels. But even after consulting with Delbruck, the work was inconclusive. Watson felt like he was hitting a wall. And then comes the great scientific epiphany, the moment that solidified his entire mission. It happened when he accompanied Kalkar to a meeting in Naples, Italy.
Yes, the fateful meeting in 1951. This is where the narrative arc of his career really takes off. He saw Maurice Wilkins present X-ray diffraction data for DNA.
And that image, that faint but compelling pattern produced by X-rays hitting DNA fibers, was the confirmation Watson needed.
What did he see in it?
He became firmly convinced that DNA possessed a distinct, regular molecular structure that could be precisely figured out, not through complex biochemistry, but through structural deduction and model building. That singular moment launched him into the single-minded pursuit that would define the rest of his life.
And that pursuit led him directly to England, to the University of Cambridge.
It did. Luria had arranged a new postdoctoral project for Watson under John Kendrew, but his real fate was sealed when he met Francis Crick at the Cavendish Laboratory.
It was an immediate intellectual spark from what all the sources say.
Oh, absolutely. Watson was only 23. Crick was 35, still working on his PhD, and already known for his brilliant, if rather loud, intellect.
And they were both model builders with a singular focus, solving the DNA puzzle. And they had a rival.
A huge rival. Linus Pauling, chasing the same prize across the Atlantic. The race was on.
And they achieved what seemed impossible. Watson and Crick deduced the double helix structure of DNA in mid-March of 1953. But let's be very clear about this. They were model builders. They weren't using experimental data they collected themselves in the Cavendish.
That's the key distinction, and it's central to the whole story. They were synthesizing data collected elsewhere. They used chemical measurements, density estimates, and crucially, high-quality X-ray diffraction images.
Images generated primarily by Rosalind Franklin and her graduate student Raymond Gosling at King's College London.
Yes. which was part of the same institution as Maurice Wilkins. The data was coming from that lab.
The impact at first was localized but profound. People like Sidney Brenner and Dorothy Hodgkin, they were deeply impressed when they saw the model. But this wasn't an immediate global headline, was it?
Not at all. So Lawrence Bragg, the director of the Cavendish, actually made the first public announcement at a Solvay conference, but the press didn't pick it up.
So the official world-changing publication came in the journal Nature.
April 25, 1953. A brief, single-page paper that began with the famously understated line, "We wish to suggest a structure for the salt of deoxyribose nucleic acid, DNA."
So understated for a discovery of that magnitude. And then 6 weeks later, Watson presented the model at the Cold Spring Harbor Symposium on Viruses, bringing it directly to the molecular biology community.
And the formal recognition, of course, came much later. 1962, the Nobel Prize in Physiology or Medicine, shared by Watson, Crick, and Maurice Wilkins.
And here we hit the unavoidable, painful historical reality of the story.
Rosalind Franklin.
Rosalind Franklin had already died of ovarian cancer in 1958. She was only 37.
Which made her ineligible for the Nobel Prize. And her absence in that award and the narrative that was later created around her brings us directly to the core controversy of the discovery story. It's an ethical and historical question that remains hotly debated today.
Okay, let's dedicate some real time to this because the sources are definitive about how central her contributions were. What were the non-negotiable pieces of the puzzle that Franklin provided?
Her work was really the foundation upon which the final deduction was made. We can break it down into three critical pieces. Three architectural constraints that she provided.
Okay.
First, her high-quality X-ray diffraction patterns, particularly the famous photograph 51.
The iconic image.
It was the clearest visual evidence for DNA's helical nature. It provided the measurements needed to determine the pitch and the dimensions of the helix. It was beautiful, precise data that no one else had managed to replicate at that level.
So she proved it was a spiral,
Yeah.
a helix. That's a huge leap forward from just speculation.
Exactly. Second, her data provided precise estimates of the water content of the DNA crystals. Now, this sounds like a minor detail, but it was absolutely crucial.
Why?
Because of that water content, Franklin realized the sugar-phosphate backbones had to be on the outside of the molecule, facing the water, while the bases were stacked on the inside.
Which corrected earlier erroneous models.
It completely corrected them. Models that had been proposed by Linus Pauling, and even an earlier failed attempt by Watson and Crick themselves, had wrongly put the backbones on the inside.
Wait, so Watson and Crick's earlier model was fundamentally wrong, and it was Franklin's quantitative data that forced the correction. She showed the spine had to be on the outside, acting as the structural element.
That's right. She was the one providing the hard architectural constraints. And third, her identification of the space group for the DNA crystals. This is a highly technical crystallographic measurement. It revealed to Crick that the two DNA strands had to be anti-parallel.
Let's pause and unpack anti-parallel for the listener. That seems to be the moment the structure really clicks into place. What does that mean architecturally?
Okay, so think of the DNA double helix not just as a twisted ladder, but as a divided highway. If one side of the helix is moving up, let's say from 5' to 3', the other side must be running down from 3' to 5'. They run in opposite directions. This concept is fundamental to how DNA replicates, and Franklin's crystallographic data was the primary source for that deduction.
So these three technical details, the helix, the outside backbone, and the anti-parallel orientation, these were the hard, non-negotiable facts needed for the final solution.
They were. And the issue, the lasting controversy, centers entirely on attribution. How did Watson and Crick get these non-negotiable facts?
And the sources note they accessed her unpublished data through three primary avenues, and none of them involved her collaboration or her explicit consent in building their model.
Correct. The three access points form the basis of the ethical critique. The first was Watson attending her 1951 seminar, though interpretations of what he retained from that vary. He later admitted he didn't take notes.
Okay.
The second was through general discussions and observations with Maurice Wilkins, who shared her lab space but had a very, very strained relationship with her.
And the third, which is maybe the most problematic from a professional conduct standpoint, was the Confidential Medical Research Council Research Progress Report.
Absolutely. The MRC report was circulated internally to promote lab coordination. It was not for external model building. And it contained Franklin's precise measurements,
Including the density and the space group information?
the key to the anti-parallel structure. Watson and Crick obtained and used this report without Franklin's knowledge or explicit permission. They essentially took the foundational measurements that allowed them to connect all the dots.
It's important to look at Watson's own shifting acknowledgement of this. The sources document a real contradiction. In 1954, right after the discovery, Watson and Crick acknowledged that formulating the structure would have been most unlikely, if not impossible, without Franklin's data.
It's a powerful, clear admission of her central role, acknowledged right there in print.
It is, but that admission stands in sharp contrast to the narrative he constructed later. In his best-selling 1968 memoir, The Double Helix.
Right. That's where the controversy became deeply personal and explosive. Critics, reading the book, immediately flagged it as containing what they called misogynist treatment. He seemed to actively give the impression that Franklin was merely Wilkins' assistant, that she was intellectually slow and somehow incapable of interpreting her own beautiful data.
The quotes cited in the source material are highly negative. They contribute significantly to this reputation. He suggested, for instance, that clearly Rosie had to go or be put in her place.
And the general tone just dismisses her as difficult and irrational. It focuses on her appearance and her demeanor rather than her scientific acumen. It's a very troubling portrayal.
And this is why the attribution remains so hotly debated. On one side, you have historians and scientists like Robert Crease and Jeremy Bernstein, who argue that while she provided essential data, the title of discoverer ultimately goes to those who performed the final synthetic act, the theoretical breakthrough of fitting all the pieces together into the double helix scheme. They reject the idea that she was a passive victim.
But then you have the opposing side. Researchers like Matthew Cobb and Nathaniel Comfort, who maintain that Franklin was, despite everything, an equal contributor to the solution of the structure.
It's an unavoidable fact that she had corrected major errors in the early models that Watson and Crick had put forward. Her absence in the Nobel context is a tragedy, but the lack of immediate, full credit, that's the lingering ethical wound.
And let's pause on the personal dimension here because this part is fascinating. Despite the brutal winner-take-all nature of the discovery, the use of her unpublished data, the controversial memoir, the sources indicate that Watson and Franklin later exchanged constructive scientific correspondence.
Really?
Yes. They wrote about her subsequent highly successful work on the tobacco mosaic virus RNA structure. They used polite forms of address, Dear Jim, signing off with best wishes, yours, Rosalind.
That's remarkable. It suggests that the raw professional animosity of that discovery moment, or at least the posturing around it, was later replaced by a more conventional, maybe even respectful scientific exchange.
It speaks to a certain detachment. They were capable of setting aside the personal drama when there was a new scientific puzzle to solve. But for Watson, the winning of the double helix race seemed to solidify a certain conviction in him.
Which was?
That intense focus, bordering on ruthlessness, was the necessary ingredient for scientific advancement.
So the product of that immense scientific success, the double helix, it set him up for a career not just as a researcher, but as a scientific leader, an institution builder. From 1956 to 1976, Watson was on the faculty at Harvard, focusing on RNA and genetic information transfer.
And those 2 decades were foundational. He wasn't just doing bench science, he was promoting the field. He became a central figure in scientific literature, not just with his controversial memoir, The Double Helix.
Which, let's remember, Francis Crick famously called a contemptible pack of damn nonsense.
He did. He suggested it was basically fiction. But Watson also published these highly influential and clear textbooks like Molecular Biology of a Gene in '65 and later Recombinant DNA. He was defining the curriculum for a new generation of biologists.
And he also showed a willingness to step into public affairs, demonstrating an early progressive streak. Our sources note his political involvement.
Right, including protesting the Vietnam War and, in 1975, speaking out against nuclear proliferation. He warned President Gerald Ford that there was no proven method for the safe disposal of radioactive waste.
That is a crucial counterpoint to his later reputation. It establishes that the young, successful Watson was socially engaged, that he was advocating for peace and environmental safety. But the real institutional mark he left was at Cold Spring Harbor Laboratory, CSHL.
Yes. Let's discuss his incredible 35-year tenure there. He started as director in 1968, and he held various leadership roles, director, president, chancellor, all the way until his first retirement in 2007.
And this is perhaps his most overlooked positive contribution. It really demonstrates his administrative brilliance.
Absolutely. He is credited with transforming a small facility into one of the world's great education and research institutions. When he took over, CSHL was respectable, but it was a niche research center.
What did he do?
He dramatically expanded funding, he restructured the research agenda, and he shifted the focus heavily toward the molecular study of cancer, alongside core molecular biology. He was a brilliant fundraiser and recruiter. He used his fame and connections to attract top talent and massive endowments. He basically built a research empire.
So the very structure and success of CSHL today is a direct result of his vision.
A direct result of Watson's vision and his relentless drive over 3 decades. It's an unparalleled legacy in that regard.
And here's where the two threads of his life, scientific leadership and public policy, converge with maximum impact. His role leading the Human Genome Project, the HGP.
He was appointed head of the HGP at the National Institutes of Health in 1990.
His time there was brief, though, only until 1992. But it was absolutely pivotal in establishing the philosophical framework for the largest biological project in history.
It was. He was instrumental in securing the early funding and structure, but his tenure ended in dramatic fashion over an ideological dispute with the NIH director at the time, Bernadine Healy.
And the dispute was about patenting gene sequences.
It was. This wasn't a minor administrative spat. This was a fundamental ethical disagreement about the ownership of the genetic blueprint of humanity. He was arguing that this information belongs to everyone.
That's right. Watson was fiercely opposed to the privatization of the genomic blueprint. He argued that allowing companies or nations to patent individual genes or sequences would create an impossible barrier to research and development globally.
He famously stated that the human genome belongs to the world's people as opposed to its nations.
This is an astonishingly progressive stance, coming from a scientist who would later become known for his abrasive conservatism. He resigned shortly after the NIH announced plans to apply for patents on certain brain-specific cDNAs. He put his conviction where his career was.
He walked away from the most important research project of the era over a principle. It's a crucial detail that often gets overshadowed by his later rhetoric. This moment shows a radical philosophical commitment to open science.
A perspective rooted in his belief that if this knowledge is universal, it should be freely accessible to benefit everyone.
But this commitment to universal genetic knowledge, strangely, was the very foundation for his later decline.
That's the tension we need to focus on. The man who fought to keep the genome open for the whole world was the same man who believed that that open data should be used to eliminate what he called bad genes. This intellectual tension is the core of his tragic legacy.
The commitment to genetic knowledge as universal property seemed to feed his later, darker conviction, an extreme form of genetic determinism. This is where his scientific genius gave way to profound public career repercussions.
Okay, let's define that term clearly. What exactly is genetic determinism, and why did it become such a dangerous lens for Watson?
Genetic determinism is the rigid belief that genes are the sole, or at least the primary cause of all human behavior, intelligence, personality, social status. It essentially eliminates any significant role for environment, education, or free will.
So for Watson, this meant believing that every human outcome, good or bad, could be mapped back to a specific set of genes.
Precisely. And he articulated this philosophy through a political lens, didn't he? He suggested that the political left disliked genetics because it implies that sometimes in life we fail because we have bad genes, and they preferred to blame all failure on the evil system.
So he's framing genetics as this inherently immutable, unchangeable determining force, which I suppose justifies inequality as just biological destiny.
And this framework provided the rationale for his specific, highly inflammatory comments concerning race and intelligence, starting around the early 2000s and continuing throughout the rest of his public life.
We must report these impartially, as they're contained in the source material, to understand the depth of the fallout.
His statements were clear, often unprompted, and frequently repeated. He asserted publicly that differences in average measured IQ between blacks and whites are due to genetics. He was arguing for a biological basis for racial intellectual disparity.
And the sources provide a specific, widely reported quote from 2007.
Yes, his 2007 comments, made during a European tour, were particularly damaging. He expressed that he was inherently gloomy about the prospect of Africa.
Why?
Because, he said, testing suggested their intelligence was not really the same as Westerners. He insisted that although everyone wants equality, the data suggested otherwise, and so aid programs should be structured around these inherent differences.
And he didn't just limit these views to the black-white dichotomy. He expanded this theory to other ethnic groups.
He did. In 2000, he stated that stereotypes associated with various racial groups have a genetic basis. For instance, he claimed Chinese people are intelligent but not creative due to centuries of social selection for conformity, which repressed genetic diversity.
I didn't it.
He suggested that Indian people are servile because of genetic selection under the long-established caste system and caste endogamy.
Wait, he was using social history, like the caste system, as a mechanism for genetic selection.
Yeah.
That implies a level of speed and precision in human evolution that seems wildly speculative.
It is wildly speculative, and that's precisely why the scientific community reacted so strongly. These statements were, by all accounts documented in our sources, unsubstantiated, reckless, and contrary to the vast consensus in both genetics and anthropology.
And what was the immediate fallout from these highly publicized remarks?
The professional consequences were immediate and severe. His European book tour was canceled almost instantly. Under immense pressure, he issued a public apology.
In
That apology was quickly followed by his retirement in late 2007 from his leadership roles at CSHL Chancellor and President. He was 79. He left, but his relationship with the institution was clearly strained.
But the institution ultimately acted even more decisively years later. The sources note that in 2019, after he reiterated these exact views in a television documentary,
He doubled down.
and CSHL officially and comprehensively severed all ties.
This action, 12 years after the initial controversy, solidified his status as a pariah. CSHL revoked all of his honorary titles, Chancellor Emeritus, Honorary Trustee, and issued a statement condemning his views as unsubstantiated and reckless. The scientific community had officially disowned one of its greatest living figures. This is the definition of becoming an unperson, a term he himself would later use.
And it wasn't just race and IQ that defined his controversial later life. He had a pattern of highly provocative remarks rooted in applying this genetic determinism to nearly every social subject. Let's look at some of these startling public comments.
Okay, take his comments on sex drive. He speculated about a link between melanin or dark skin and stronger libidos.
Right.
He said, that's why you have Latin lovers. You've never heard of an English lover, only an English patient. Again, a claim rooted in biological speculation without any scientific foundation, but delivered with maximum public offense.
He also entered the morally fraught territory of eugenics when discussing public health and society.
He was particularly focused on the concept of stupidity. He stated that stupidity is a disease and proposed that the really stupid bottom 10% should be cured through genetic intervention.
And beauty as well.
Furthermore, yes, he suggested that beauty should be genetically engineered, saying, "People say it would be terrible if we made all girls pretty. I think it would be great." He saw the potential for genetic technology as a tool for radical human aesthetic and intellectual improvement.
That's a startling jump. Moving from curing disease to engineering for subjective beauty, what about his views on sexuality?
In 1997, he weighed in on the ethics of preemptive genetic screening. He stated that if a gene for sexuality were found and a woman decided she didn't want a homosexual child, she should be allowed to choose to terminate the pregnancy.
And sources note that supporters like Richard Dawkins argued he was just being pro-choice.
They did. They argued Watson was applying the principle of choice generally, but critics saw it as endorsing selective eugenics against sexual minorities.
And then there's the professional life comment, which reveals his uncompromising nature toward colleagues and employees.
Yes, the comment about obesity. Whenever you interview fat people, you feel bad because you know you're not going to hire them. This whole catalog of remarks just illustrates how his later life became defined by a willingness to publicly pronounce these highly controversial, often offensive, and scientifically dubious opinions.
All based on his absolute belief in genetic reductionism. He seemed to conflate his immense authority on DNA structure with authority on sociology and ethics.
He did. And his abrasive personality wasn't just reserved for the public, it extended to his scientific rivals. In his memoir, Avoid Boring People, the sources note he liberally characterized colleagues who disagreed with him as dinosaurs, deadbeats, fossils, and vapid.
This tendency for personal attacks culminated in that spectacular long-running feud with fellow geneticist Craig Venter.
Yes, his competitor in the race to sequence the human genome. Watson, in his famous temper, called Venter Hitler.
There's not professional rivalry.
That's scorched earth rhetoric. It illustrates his tendency toward absolute dismissal of anyone who challenged him or his ideas.
And this abrasive quality was recognized even early in his career. E.O. Wilson, another giant of biology who worked alongside Watson at Harvard, initially described him as the most unpleasant human being I had ever met.
He did, though he later softened that view, claiming they were friends and their Harvard rivalry was old history.
But the initial description sticks, doesn't it? Watson clearly relished playing the role of the provocative antagonist, someone who believed his intellectual superiority gave him license to offend and dismiss others.
He really did.
So we move now to the final chapter of his life. Despite being marginalized and eventually exiled by his own institutions, he remained active in science, still seeking to push boundaries. In 2007, the same year as the height of the controversy, he achieved a milestone in personalized medicine.
That year, he became the second person, right after his rival, Craig Venter, to publish his fully sequenced genome online, and he did this with a clear, radical purpose.
Which was to encourage personalized medicine and disease prevention.
Exactly. He wanted the information contained in genomes to be instantly accessible and used to identify and prevent disease. It reflected his deep-seated belief in the radical application of genetics for human improvement. The sequencing itself was a symbol of his commitment to open, applied science.
And he also pursued unorthodox research, demonstrating his lifelong willingness to challenge established paradigms, even late in life. In 2014, he published a paper in The Lancet.
Right, suggesting a novel, counterintuitive view of chronic diseases like cancer and diabetes.
This is a great example of him trying to shift consensus again. Traditionally, these chronic inflammatory diseases are linked to excessive oxidation, right? Too many free radicals causing damage. What did Watson propose?
He proposed the exact opposite. Watson suggested that the root of inflammation in these diseases was actually a lack of biological oxidants, not an excess. He argued that instead of overloading the body, we are deficient in the specific molecules needed to regulate inflammation effectively.
And that paper, published when he was 86, generated its own small scientific controversy.
It did. Some critics suggested it was published purely due to his towering fame and lacked sufficient experimental merit. They questioned why such a speculative paper would appear in such a prestigious journal.
But others supported him.
Yes, other scientists came forward to express support for his hypothesis, noting that it offered a fascinating new angle for research, particularly concerning cancer progression. Even in his late 80s, he was still trying to shift paradigms.
Then we come to the profoundly symbolic action of 2014, the sale of his Nobel Prize medal.
It was an unprecedented event at the time. The first living Nobel recipient to auction a medal, Watson sold it for $4.1 million US.
And he stated quite plainly why he did it.
He said he did so because he had been made an unperson and had lost significant income following his controversial statements and subsequent marginalization.
He used the sale, this public symbol of his exile, to fund science itself, directing the money to research at Trinity College Dublin and to conservation work.
And the story of the medal has a strange and public coda. It was later purchased by the Russian oligarch Alisher Usmanov,
Who then returned it to him.
who promptly returned it to Watson, stating that a distinguished scientist should have the medal belonging to him. So this act closed the loop on a very public declaration of his exile, somewhat cushioning his final years.
And on a more personal note, the sources highlight the tragedy of his son, Rufus, who has schizophrenia. Watson actively sought to encourage progress in understanding and treating mental illness through genetics. It shows a very personal investment in the applied science he championed.
He saw his own field as the necessary solution for his family's suffering. And throughout all this, we have to remember his core philosophical stance. He was a lifelong atheist and a signer of the Humanist Manifesto. He adhered to a rational, scientific worldview that sought natural explanations for all phenomena, whether biological or social.
James Dewey Watson died in East Northport, New York, in November 2025 at the age of 97. His death brought immediate media summation of his legacy, and the verdict was and remains definitive.
The final assessment in the media consistently reflects the profound duality we've discussed. His work opened the door to modern molecular biology. It set the stage for rapid advances in everything from medicine to forensic science, fundamentally changing our understanding of life forever. But this immense scientific triumph, the sources all conclude, cannot be separated from the destructive legacy of his racist and sexist comments.
It's the ultimate defining contradiction. a scientist dedicated to the pursuit of objective truth and open knowledge, whose own severe intellectual biases led him to publicly state falsehoods, or at best, dangerous, unsubstantiated claims that were immensely damaging to his reputation and the institutions he served.
The sources reveal a life consumed by intellectual radicalism. He was capable of fierce moral clarity, as we saw in his opposition to patenting the human genome, but simultaneously demonstrated a staggering lack of ethical restraint in applying his beliefs and genetic determinism to social issues. He was a monumental scientific life consumed by profound ethical failure. A cautionary tale, really, about the limits of scientific authority when applied outside its domain.
That brings us to our final synthesis. We've documented the fierce brilliance of Watson, the co-discoverer of the double helix structure, a profound, world-changing breakthrough that remains the centerpiece of modern biology.
And we've juxtaposed that achievement with the destructive nature of his adherence to genetic determinism and his public propagation of unsubstantiated racist and sexist ideas, which ultimately stripped him of his institutional standing.
His career reveals a deep, defining tension. A tension between the radical pursuit of knowledge and the ethical responsibility required once that knowledge is acquired and publicized.
His vision, born from the perfect symmetry of the helix, led him to simultaneously demand that the human genome be accessible to all as universal property, yet suggest it should be used to eliminate perceived defects like stupidity or lack of beauty.
The sources show he viewed the genome as a common resource, an instruction manual that should be read and applied universally without national or corporate barriers. But his vision for that application was radically utilitarian, pushing towards a form of eugenics motivated by his personal, often offensive, judgments.
And for you, the learner, the sources point to a final provocative thought built on this very tension. Watson was fiercely opposed to the patenting of the human genome, believing this essential information belongs to the world. Considering the immense power he unleashed, the era of personalized medicine and widespread genetic screening, the source material suggests his goal was the radical, total application of genetics, even to the point of curing stupidity or engineering beauty.
So the question we leave you with is this. If the structure of DNA truly belongs to everyone, as Watson argued so passionately, how do we ensure that the revolutionary knowledge derived from that structure, the ability to identify and possibly manipulate genetic traits, is applied ethically and universally, rather than becoming a tool that reinforces or leads to the very social or racial division that characterized his most controversial rhetoric? Go and think on that.
An important challenge to close out this deep dive. Thank you for joining us as we unpacked the complex, contradictory life of James Watson.
We'll see you next time.